So now that we're getting into antiderivatives, we're going to work our way through day 47 in the notes. So I've got my notes and we are on page 487 right now. And so what we're going to be talking about here is finding antiderivatives of polynomial type functions. We'll say polynomial type because it'll be a little bit odd, as we'll see. So first question here is, if you had to explain to someone how to find the derivative of, let's say, a real polynomial, what would you say? How would you find the derivative? Like if I asked you to find the derivative of 4x cubed plus 3x squared minus 7x plus 4, what would the steps be for that? So pause the video, write that out in your own words. All right, so here's the way I would describe it. Let's say for each term, what we did is, let me give myself an example right here. So if I had like 3 times x to the 5th power, all right, I would multiply the coefficient by the exponent, and then I would reduce the exponent by 1. Right? So that's the step. That is the power rule. And we apply that to every term in the polynomial, and we're where we need to be. So now to find the antiderivative, just like we're always when we're finding the inverse of an operation, we need to do the opposite of every step in the reverse order. So the way you might think of that, the way I describe inverse operations back in Algebra 1 is I say, let's think about getting dressed in the morning. All right, so the first thing I do is I put on a shirt, then I put on my sweatshirt over that, and then I put on my coat in order to go outside. So it was really important, the order in which I did those things, because I'd look pretty silly if I did it in a different order. But when I get home at the end of the day and I want to take it all off, I need to undo those operations, but I need to do it in the reverse order of the order I put it on. I put my shirt on first thing in the morning, but I can't take it off first because I've got my sweatshirt and my coat on over it, right? So the first thing I have to take off is the last thing I put on. I've got to take off my coat and then take off my sweatshirt, and then I can take off my shirt. Okay, so I'm sorry to have given you that image, but let's go back to the question that we were talking about. So in order to find the antiderivative, we've got to do these two steps in the opposite order. So for each term, we need to, first thing we need to do is we need to add 1 to the exponent. The opposite of subtracting is adding, and then the opposite of multiplying the coefficient by the exponent is we need to divide the coefficient by the, and let me make it clear that I'm talking about the new exponent after we added exponent. And let me jump down here and solve this first problem just so we can practice this process. So we want to find the antiderivatives. So our first term is 3x squared. So when I change it, I need to turn it into x cubed, and then I need to divide 3 by 3, and that would be 1. So my first term is just going to be x cubed. Let's double check that. Is the derivative of x cubed 3x squared? Yes, it is. So that was the right step. And the next step is 2x. We're going to add 1 to the exponent, so it becomes 2, and then 2 divided by 2 is 1. Once again, the derivative of x squared is 2x, so I feel good about that. The last term here is 3, and that's going to be 3x. Okay, Now the thing they say here is that the antiderivative of the function is denoted by this notation, the indefinite integral notation that I talked about in the last video. So when finding the antiderivative of a function, you're finding the function of which f of x is the first derivative. This will enable us, we'll see in future videos, if we're given the first or the second derivative, we'll be able to find the function itself. However, if the integral of the first derivative of x dx is equal to f of x, what problem do you foresee? And the thing they're looking for here is the same thing we observed in the last video, which is that we need to account for the possibility, and you can write this in your own words, of course, of a constant term in the antiderivative. Antiderivative by adding a term of capital C. Okay, or something like capital C. You'll see examples by the end of this module of sometimes when we need to think about more than one variable there. So when we talk about the antiderivative of this, we want to say x cubed plus x squared plus 3x plus a constant. Okay, so in the next video, I will go through the rest of the examples on this page and we'll see how to go through and solve those.